Good morning to all. Now in this session we are going to continue problems on inverse Laplace transformation. Now some questions are being asked repeatedly in examinations. So first we have to observe what kind of problems they are giving. Now just I am writing one problem, just look at, which is being asked repeatedly. F of s is equal to s plus 4 by s into s minus 1 into s square plus 4. So this problem was asked three times. Now, so here whenever a problem is given like this, s plus 4 by s into s minus 1 into s square plus 4, now just look at, observe very keenly. The power of s in the numerator equal to 1, but equal to the power of s in the numerator equal to 1. The power of s in the denominator equal to s into s square into s square is equal to 4. That means what? The power of s in denominator, the power of s in denominator is greater than the power of s in the numerator. This is very important first. The power of s should be greater than that of the power of s in the numerator. Now, in this way, how many factors are there? 3 factors are there. What is the power of s? Linear 1, therefore let it be a by s. Next, what is the power of s in the second factor? It is also power of s equal to only 1 only. Therefore, let it be b by s minus 1. Now, what is the power of third factor? It is quadratic, not linear. In this way, just you are supposed to make it c s plus d by s square plus 4. Now just look at, these two are linear. It is of quadratic nature. In the quadratic nature means what? One more s variable cs plus d should come. Let this equation be 1. Equation be 1. Now for this one you have to find LCM of the entire fraction. So what you get, LCM s minus 1 into s square plus 4 plus b into s into s square plus 4. Second one, cs plus d into s into s minus 1. Now just look at, this is the way of finding LCM both sides. Now here you can put s equal to 0. S equal to 0 means what? This term and this term it gets cancelled. Next one, keep s equal to 1. This term and this term will be cancelled, b will come out. How many variables are there? 4. How many constants are here? 4 constants, a, b, c, d. So we need 4 different equations for solving 4 numerical constants. Then you have to make it comparison of s cube terms or comparison of s square terms. Here comparison of s term constant. Here you are having s term and a constant, comparing s terms both sides. Next one, comparing constant both sides. In this way you can get, after that comparing coefficients of s and constant for both sides. In this way, upon solving this one, we get a equal to 1, d equal to 1, b equal to 0 and c equal to 0. Understanding? So here actually Upon solving this, A equal to, now upon solving this, S equal to 1 and comparing coefficients of S and for both sides, we get A equal to D equal to -1, next B equal to 1 and C equal to 0. These constants we get. Okay, so this is very important. A equal to D equal to -1, B equal to 1, C equal to 0. These constants we get. So now put the values of 2 in the equation 1. Now we have S plus 4 by S into S minus 1 into S square plus 4 equal to A equal to how much? Minus 1. So here keep A equal to -1. This is -1 by S. B equal to how much? 1. This is 1 by S minus 1 plus C equal to 0. This becomes 0. That means in place of A, we are keeping -1. In case of D, -1. In place of B, 1. In case of C, 0. How we are substituting, look at. Now C equal to 0 means C's term is missing, vanishing. Now D, that will become -1 by, this will become S square plus 4. S square plus 4. Got it? Now, taking inverse Laplace transforms, both sides, we get S plus 4 by S, S minus 1, S square plus 4. This is inverse Laplace transformation. Now apply the same inverse transformation to the right hand side for each and every term individually. Keep always constants outside of the transformation for our easy inverse transformations. -1 by S. So minus is constant, keep minus L inverse of 1 by S. Next, no constants here. Therefore, L inverse of 1 by S minus 1. So here no constants. So here minus L inverse of 1 by S square plus 4. Now just look at, just as discussed in the previous problem, what we discussed, Laplace transformation of 1 equal to 1 by S. Therefore, L inverse of 1 by S equal to 1. So in this place, what we have to make it? -1 plus, one other one, Laplace transformation of e power t equal to 1 by S minus 1. Therefore, inverse Laplace transformation of S minus 1 equal to e power t. So in this place, you can make it as e power t. Understanding? Next one, minus, one more point, Laplace transformation of, here in case of 4, you can make it, how you can write 4? 4 can be replaced as S square plus 4 we have. 4 can be written as S square plus 2 square. S square plus 2 square. Now the formula, Laplace transformation of sin 2t equal to a by S square plus a square, that is equal to 4. Therefore, inverse Laplace transformation of 1 by S square 4 equal to 1 by 2 sin 2t. Keeping this t this side, it multiplies. Therefore, here in this place, we keep half sin 2t. Half sin 2t. So this is the output of this inverse Laplace transformation. But better to keep always positive term in the first place. Better, that is the tradition. So now just we are making e power t minus half sin 2t minus 1, or you can keep it as half outside. This will become 2 e power t minus sine 2t or minus 2. So this will become the actual signal f of t. This will become the actual signal f of t. So now just look at what is given to us. S domain. S domain means what? Frequency domain given. What we found? Time domain. So for converting S domain into time domain, we use what? Inverse Laplace transforms. Inverse Lap. These are obtained only for the Laplace transforms only. Taking L to LHS, it will be RHS, it will become inverse Laplace transform. Understanding? So problems like this problem was asked 3 times in OU examinations. So here keep the power of the numerator and always keep the power of S in the denominator. The power of S in the denominator should always be greater than that of the power of the S in numerator. In that case, just observe how many fractions are given to us. 3 fractions. 3 factors are given. So now we have to make 3 fractions. If there are 4 factors, go for 4 fractions. Now the first one degree is 1. Therefore, we have written only linear. A non-linear, A by S. Now here the degree equal to 1, they go for only constant S minus 1. But the third one is that of quadratic. So we have to go for linear. CS plus D. After that go for LCM, both sides. So LCM both sides means you will get like that. Don't write these words continuously. Students will be confusing. Just write in this way. You have to write in this way only for comparing coefficients of S, S square, S cube and constants. Understanding? Your visualization will be focused on a particular place only. Don't go for sequentially writing. Step by step you write. After that comparison makes you get the values of A, B, C and D. Substituting these values here in the given equation, you will get